In this video, we're going to look at two questions on momentum. So, for the first question, it says a ball of mass m and velocity u collides elastically with a larger ball of mass capital M initially at rest. The ball of mass m rebounds along its original line of motion with speed v1, and the ball of mass capital M has velocity v2 in the direction of u, so that is the initial direction. Now the first component of the question asks to write down the conservation equations for the system. And so for this system, there should be two conservation equations. The first one is for momentum, and the second one is for kinetic energy, because it says the particles collide elastically. The balls collide elastically. So for first, we can say mu and the momentum of capital M initially is equal to 0 is equal to m times negative v1, because it's in the opposite direction. That will be negative v1, mv1, and then plus mv2, because it's in the initial direction. And for the second equation, it will be the conservation of kinetic energy, and that will be a half mu squared is equal to a half mv1 squared plus a half capital mv2 squared. And this will be the answer for the first component of the question. So, and then for the second component, it asks to deduce the result that u minus v1 is equal to v2. What we can do is to essentially work with the prior two equations. So let's look at the first equation first. Mu is equal to negative mv1 plus capital mv2. So we can move the term of m to one side and factorize it out. And I think this is sufficient. And then we can look at the other equation. So we can cancel out all the 1/2's, and then we can move other term with m to one side and then factorize m out, which leaves us u plus v1 squared. Sorry, u minus v1 squared is equal to a half. The all the 1/2's is gone, so it will be mv2 squared. Then we can actually further factorize, because u squared minus v1 squared could be factorized into u plus v1 times u minus v1. And we can now divide the two equations. So let's say this is equation 1, this is equation 2, then equation 2 over equation 1 would be the m cancels out and u plus v1 cancels out, so what's left will be u minus v1. And then for the other part, the one set of v2 will be cancelled out, and m will be cancelled out, capital M. What's left will be v2, and that will be what the question wants us to prove. This will be the answer. And then for question 2, it says an excited neon 2 isotope travels with a velocity of 3 times 10⁶ meters per second into the detector and this integrates into an alpha particle and oxygen 16. Okay, and then the event produces an additional 6.25 mega eV of kinetic energy. The oxygen nucleus leaves the event at right angles to the path of the original neutron nucleus, and then it asks us to determine the velocity of the alpha particle. Relativistic effects may be neglected. Okay, and then it gave us the value 1 eV. Okay, so what we can work with first is the momentums, with the conservation of momentum horizontally and vertically, and then we can look at the conservation of energy, because the question gave us, it says additional kinetic energy. So we can look at the horizontal momentums first. Firstly, for neon 2 isotope, we can say its mass will be 20 U for atomic mass unit, and then we can later derive an exact value for it. So this is time by its velocity. It is equal to, for the oxygen 16 molecule, it's moving at right angles. If it's moving at right angles, this means that it doesn't have a horizontal component for its velocity, hence we can neglect it. And then what's left is just the alpha particle. So alpha particle is composed of 2 protons, 2 neutrons, so we can say it's 4U times its velocity. Its velocity, we can say it's V alpha cosine theta for some angle. And then we can solve for V alpha cosine theta. The U's cancel out, so what's left will be this. And I think then we can move on to the conservation of vertical momentum. So firstly, the neon 20 isotope, for its momentum it will be 0. And for oxygen 16, it will be 16U times some velocity, let's say VO. And then we have to consider momentum with the alpha particle. And because we set the direction of oxygen 16 as positive, this means that alpha particle will be negative. It will be negative. Negative for U times V alpha sine of theta. And then we can resolve for V alpha sine of theta will be equal to the U's cancel out again. That will be 4 VO. And then there is actually something you can do further with these two equations, because the angle in this case isn't actually involved very much in the equation, so we have to remove the sine and cosine, or else we will have too much variables. And so all we can do is utilize the equation sine squared theta plus cosine squared theta is equal to 1, and say equation 1, equation 2, then we can add up the square of the two equations. Therefore, we will be able to cancel out the sine and cosines. Okay, so firstly, it will be, for equation 1, it will be V alpha squared times cosine squared theta plus V, this is equation 1 plus equation 2 squared, alpha squared sine squared theta is equal to the, let's see, 15 squared is 200, 225 times 10 to the power of 12 plus 16 16 VO squared. And we can factorize out the V alpha squared, and then the sine squared theta plus cosine squared theta will be equal to 1. So what's left will be V alpha squared. It is equal to 16 VO squared plus 225 times 10 to the 12. Okay. And I don't think we can actually further simplify this, so we can look at the kinetic energies now. So for KE, what we can do first is that it produces additional kinetic energy. So this means that it's in addition to the kinetic energy of the neon 20 isotope. And so we can write out the equation first. A half times the mass of the neon 2 isotope, that will be 20U times its velocity squared, which is 9 10 to the power of 12, plus 6.25. However, it's in mega eV, so we have to time it by 1.6 times 10 to the negative 19 times, because mega, so it's 10 to the 6. And then this is equal to the velocity, the kinetic energy of the alpha particle first. This will be 4U times its velocity squared, which is V alpha squared, plus the kinetic energy of the oxygen 16. That will be 16U times VO squared. Now, we can simplify this equation first. So it's 10U times 9 times 10 to the power of 12, plus this, we can resolve this first, and then this will be 10 to the negative 12 is equal to 2U times V alpha squared plus 8U VO squared. Okay, now we have something to work with. So there's currently 2 variables. Equation we can do is replace or substitute one of the variables, and if we look at the prior equation, we can isolate VO first because we want to resolve for V alpha. So let's so for VO in this equation, so VO 16 VO squared is equal to V alpha squared minus 225 times 10 to 12, and so VO squared will be equal to and now we can put this into the equation. So this can be further simplified into 9 times 10 to the 13 U plus a 10 to the power of negative 12 is equal to 2U V alpha squared plus 8 cancels out with the 16, so what's left will be this over 2. And now we can simply resolve for V alpha. is equal to 2u. We can combine these two terms, which gives us 5 over 2 u v alpha squared minus 225 divided by 2. That is 112.5 times 10 to the 12 times u. We are getting closer now. And then we can move it to the other side, which gives us and I think this is the time for us to plug in the value of atomic mass unit. So let me write out this first. So now we need to solve for this. Okay, this will be a rather long equation. And then we will get approximately 3.21 times 10 to the power of 14, and so V alpha will be equal to the square root of this, which is approximately 1.8 times 10 to the 7 meters per second, and this will be answer to this question.